This is a nice true-false problem that will help us learn about limits looking at a graph. So let's start with A. The limit as x approaches -1 of my function is equal to 1. So here I am on A. So as x is approaching -1, so here's -1 right here. So on my function f of x, as x is approaching -1 from the positive side, is my limit, so I'm getting really, really close to -1, not quite at -1, is my limit 1? I think so. My y value there is 1. The limits are y values, so I'm going to say that A is true. Let's look at B. So this is saying, as x is approaching 0 from the negative side, is my limit 0? So here's x equals 0, and I'm approaching it from the negative side, so I'm coming at it this way here, and I'm getting really, really, really close to x equals 0, but not including x equals 0. Is my limit look like it's y equals 0? Yes, I think that's true. Now, I can see that at 0, when x equals 0, my y is equal to 1. But the limit is as it's getting really, really close to, but not equal to. So this one there is true. Well, if that one is true, then C, which says as x is approaching 0 from the negative side, the limit is 1, well, that one is false because, you know, the limit's a limit. You can't have it two ways. As x is approaching 0 from the negative side, it is true that f of 0 is 1, but the limit as x is approaching 0 from the negative side is 0. It is not 1. So that one is false. Going over to D, well, the limit as x approaches 0 from the negative side, we've already determined that that limit right here is 0. And as I'm approaching 0 from the positive side, so let's approach 0 from the positive side. Yeah, I think I'm getting really, really close. I think it is also 0. So this one, D, is true. Those two limits are equal to one another. Which brings us directly to problem E, which says the limit as x approaches 0 exists. Well, that is a result of what we found in D. If the limit approaching C, or any number, in this case 0, is the same approaching from the negative side as it is approaching from the positive side. If those two are equal, then we can just say, well, we've got a limit. And one of the ways I kind of like to look at that is by thinking about two halves of a pie. So if this is a cherry pie, 2 R's, cherry pie, and this is a green apple pie, and I put them together. Let's go ahead and put them together here. I'm going to put them together. Whoa, don't do that. Come on. Let's move them over here. I put them together. I mean, I don't really have one pie. I still have two halves of a pie. I have a left side of the pie and a right side of a pie. But if they were both cherry pies, and I put the two halves together, then I would have one pie. So like I have one limit as opposed to just separate positive and negative limits. I hope that was helpful, not just disturbing. Well, back to the problem. F, well, we've just discussed that, and that is true. Not only does the limit exist, as x approaches 0, we've determined that the limit is, in fact, 0, because both the left-hand side and the right-hand side are equal to 0. So both E and F are true. Let's go to G. Again, it's saying the limit as x approaches 0 is equal to 1. Well, we've already determined it's equal to 0, so F can't be true and G be true at the same time. But what they're trying to get you to think here is that because because f of 0 is equal to 1, right there, you still have to know that the limit is as I'm approaching 0, not at 0. I'm getting really, 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 really close. What it is at 0 is irrelevant. It's really as I'm getting really, really close, that's what determines the limit. So this is false. Let's go to H. So H is one where I have to be pretty careful, because it's saying to me the limit as x approaches 1. Now you'll notice that 1, it does not say as x approaches 1 positive, and it does not say as x approaches 1 negative. No, wait, please. It just says as x approaches 1. And we just discussed, in order for it to have a limit without this positive or negative sign, the limit as it's approaching from the positive side has to be equal to the limit as it's approaching from the negative side. So let's take a look at this particular problem. As I'm approaching 1 from the negative side, my limit of f of x looks like it's going to get really, really, really close. And it looks like as I'm approaching, from the negative side, that my limit is going to be 1. So I'm going to say as x approaching from the negative side, my limit is going to be 1. But as x is approaching 1 from the positive side, it looks like my limit isn't 1. It looks like my limit is 0. So my negative side limit, which is my right-hand limit, and my positive side limit, which is my left-hand limit, they are not equal to one another. So h, the limit as x approaches 1, does not exist. D, N, E. So h is false. And similarly, I is false, because as x is approaching 1, again, they aren't the same from the positive side and the negative side. So it's not like I'm choosing which one I want to be the limit, 0 or 1. The limit is, there is no limit without a positive or negative sign. So this is what's making this one false. And then I move on to J, which says the limit as x approaches 2 from the negative side. Well, as I'm approaching 2 from the negative side, I know, it looks to me like my limit is y equals 0. I don't even have a 2 up here. So this is also false.